Okay, so again, yeah, so we took out the x to begin with, hopefully that made sense. But then when you break up a trinomial, you have to break up the front item, and you have to break up the back item. And so that's why we went with 8 and 1, because it's plus minus, and that will make 7 in the center when you add them. Positive 8, negative 1.
Yeah.
So there's no number out front, and that's why.
Bless you.
Yeah. So if you didn't hear Isaac here, he said, how do you know that 8's the only thing making the 7? Because you're absolutely right, there was no number out front of the x squared, so just the 8 is making the 7, and it's not a mixture of others. I'll try to do that in like the next problem we do, the second one. I'll try to put a number out front that makes it a little more difficult.
Alright.
Okay, so we have to actually take a little bit of time to do it.
Never do it.
Okay, now what are the X-intercepts here?
0, 1, negative 8.
0, 1, and negative 8. It's always the opposite of each of those. Now, this is the one that usually gets people. If there's a variable on the outside, like a common factor, and it's a variable, then it would be 0.
What if it's like a 4x?
If it's 4x, it would still be 0. If it was just 4, you don't have an x-intercept. It has to be a variable to be counted. Okay? Because what you do is you set each of them equal to 0 separately, and that's what would tell you x has to be 0.
Oh, it doesn't.
So. All right. Now, let's keep going. So I have 3 x-intercepts. Now, we have a 0, a negative 8, negative 8, and a positive 1. Okay. Now, the next thing that we need to look at. The next thing. What is the multiplicity? And this is something I haven't brought up to this point yet. What is the multiplicity on these x-intercepts?
I really wouldn't it be 1 for
Ones,
all?
ones,
Oh,
and a 1.
So it would be considered. They all go better.
So it would be considered each one 7.
I didn't know.
Yeah.
None of them bounce.
None of them bounce. That's what I'm basically saying.
I am brown, none of them blonde ever again.
Like say,
X plus 8.
like you can't have one of the lines going through 2 of those coordinates at the same time.
No.
Okay, so they're each individual on each other. Okay.
Okay, so if you didn't hear that,
It's a cool fact.
so we have a multiplicity here of 1 in every single variable. Each parenthesis, there's only 1 of them. So maybe on the next example, I'll make something up where there's 2. And the idea is that since the multiplicity, the greatest power in each of these parentheses is a 1, you are passing through every x-intercept. If any of these had maybe a power of 2, then you would bounce off of that particular x-intercept. Okay? Questions on the
What's a
x?
multiplicity mean?
Multiplicity is the power. Oh, on the
Yeah, that
item.
makes sense.
Okay, all right.
Where'd you get that jacket? Is it a soccer one?
Yeah. Okay,
Snazzy.
now, vertical asymptote. Okay, vertical asymptote.
We plug in.
We have to factor the denominator. Okay, Brian just checked.
Hey, you're
All right. So we set this equal to 0 because we can't factor anything. It's just, you could take a common factor, which it would show you the same result. 5x is equal to negative 10 divided by 5, and your x-intercept, or sorry, the vertical asymptote is at negative 2. So this is a vertical asymptote. Now, if you didn't want to solve that thing equal to 0, this is the other way you could have done the problem. You could have factored out a 5, and that would also make this a negative 2. So if you want to factor everything, it would still give you the individual numbers. I didn't need to factor that one. It didn't need to be factored. I could just set it equal to 0. But we have an a vertical asymptote at negative 2. Again, why that's the vertical asymptote is because you cannot divide by 0. So that would make 0 at negative 2. Okay, questions?
Oh, okay.
So we have a vertical asymptote. So in this drawing, we only have 2 pictures. The left side of the vertical and the right side of the vertical. There's only 2 things happening. All right. Now.
Oh, yeah. Take the teeth out.
Okay. Next thing, Y-intercept.
Plug 0 into everything.
Plug 0 into everything. I can already tell you what a Y-intercept is. It's going to be at 0, but because I can already see the top is there. So you plug in zeros into everything. 0, 0, 0, 0 divided by 10. 0 divided by 10 is still 0. So
It's always 10.
You say
Y-intercept.
10, Brody. 0 divided by 10 is 10.
Okay, so you plugged in zeros into all the x's. And we figured out my Y-intercept turned out to be a 0. 0 divided by 10 is still 0. And I did have a Y-intercept at 0 anyway. Okay, even if it's a weird decimal, fine and dandy, just go for it. Okay, horizontal. Okay, for horizontal asymptote or slant, these are where the 4 rules come into play for horizontal or slant. First rule, I might have to write these down because every time I say them, I just get people looking at me like a deer in headlights. If the numerator,
Specifically me?
if the numerator is greater than the denominator in terms of degree, in terms of degree,
There is no.
then there's no horizontal.
Yeah, there is no.
Okay. So in this case, there is no horizontal to this problem because if you look, my numerator is bigger than the denominator in terms of power. So this one's automatically no horizontal.
But he's not looking though.
Okay. All right now, if the denominator is larger than the numerator.
Yeah, you must have signed both of them.
Put some of it
Yeah, I was
back.
confused for a
Oh,
second.
you have
to
to
do that. You have to redo it over.
It's in my head.
It bothers me. Same with the green color, mine's so bothers me.
It doesn't matter for me.
All right.
Exactly.
So, if the denominator is larger than the denominator, if the denominator is larger than the numerator in terms of degree,
No slant.
there is a horizontal at 0. Okay, there's a horizontal at 0. If that's if the bottom is automatically bigger than the top. And then the next one is if they're the same degree, denominator is equal to the numerator in terms of degree, you have to divide the 2.
Way to go, coefficient muscles.
Okay. Hey, I don't want to hear a bunch of talking. It's kind of annoying it right now. So you divide the leading coefficients.
I think he's referring to the 2 people on the south side of the room that are talking.
They don't even know.
He just asked you to quit talking. So now we just draw.
So now we can draw. Now, the one thing I didn't discuss yet is this is the part that most people are always asked, like, or how do you know where the tails are going? Like, how do you know if the tails are going up, or down, or where they're going? Because I'm making an educated guess, right? I also think about end behavior, and this is something we haven't talked about. This is something we did in pre-calc. The tails, where the tails end up going. How do I know? Well, think about this. When we talk about in pre-calc, the tails go the same direction if your power is even. They go opposite directions on the outside. So I'm talking about end behaviors. They go opposite directions if your highest power is odd. Well, here's the idea. If you divided these 2 terms, x to the 3rd divided by x, what would you get? X squared. That means your degree, if you were to actually divide these things to make it a polynomial again, you would have an x squared graph. That's a quadratic. Quadratic, the tails go the same directions. So they're going both up. So the outside tails are actually going to go up.
Anybody ever call you a savant?
So no, definitely not. So,
I do.
For the first time, then
so
you're a savant.
okay. I'm not. Anyway,
Genius?
so this is kind of what I'm thinking, is that this is kind of the graph. So I'm thinking that on this side, since I'm passing through,
Gotta go down.
I'm thinking it's probably just doing something like this, maybe hugging up against it. There's probably a little bit of a curve there, because it's got it on the outside, the tails have to be going up. So over here, since I'm passing through both of these, it's probably doing something like this. It's probably doing something like that. That's what I'm betting.
If you were betting, man, that's what's happening.
Yeah, that's, if I was kind of betting, I'm thinking that this is probably the overall graph. Now, if we do it into Wolfram Alpha, or we do it to some graphing program, I'll just type it in my, I want to have my graphing calculator here. If we were to type it in, again, this is an educated guess of where this thing would go. You gonna type it in Desmos?
Yeah.
Okay.
Email me.
All right. Questions on all the stuff we talked about up to this point? All right, now the next one that I'm going to do. The next example after we see what this final graph looks like. I'm thinking that's probably roughly about what it's going to look like. It could be way off. I'm just making educated guesses here. All right. Now, the last thing I want to make sure of. Maybe we do one where we have some type of horizontal
And balancing.
and balancing off the x-axis. Okay.
Let's
So
make it-
we'll make one where maybe the denominator is too big.
Let's get deep into this.
Actually, not bad.
Yeah, you're a genius.
Let's see it.
Pretty good.
Word's a genius.
So it does bounce off it though.
No, on the one we just did, it was passing through the two X-intercepts. So,
Oh, it just went straight across.
no, this is that right side.
Right, it went down just like you drew it.
Yeah, and then this one on this side curved.
Yeah.
Yeah.
It'll just be weird.
Okay.
Word, you're a genius.
Yeah, it's not too bad. Well, just kind of going through the rules so you don't. It's not like it's. Oh, sorry. It's not like it's super difficult. You just have to know like how to piece things together, and then there's really only one option for the drawing. Once you get kind of all the things laid out, the problem is just knowing all the rules and how to use them. So, all right, let's go through another example. This is my last example of the day. Last example, and then I'm going to turn you loose on homework. That's going to be due at the end of the week.
Oh, really?
Darn it.
do tomorrow.
No.
Don't make you do it tomorrow. Shut up. Oh, Brandon. You're ready to do it. Go ahead.
All right, here we go.
Just give it to her.
All right, we want to maybe a horizontal at 0. So make the bottom too big. we wanna
Ward,
make it
what's your
bounce.
password?
So let's kind of mix everything together here. So let's go with 6x squared minus 12x. And let's go with 8.
I never thought of this.
Squared.
Oh my god.
32x plus.
No, two dicing.
Yeah, I'm gonna get to that very quick.
Oh no, I no. Yeah, we can do this. We can do this. It'll be fine. Yeah.
Alright, so I had to set it now.
Oh, goodness gracious.
All right.
Ward, what's your password? I
You've
turned
never
it
had it
off.
where there was less terms on the.
I tried to screenshot it and I turned it off on accident. What if that happens
Or
again?
you've never had it where there was less terms on
You
top.
just get this done, right?
Also, we have to divide the load.
Oh wait, it's still plus 0.
Yeah.
Yeah.
You just put it in there with your imagination.
Actually, this one will have a horizontal at a certain number. It won't be at 0, but it'll be really close to it. It'll be at 6/8. But
Gosh darn it, he's already got it figured out.
all right. So
That big beautiful brain of yours.
stop. All right. So let's factor the top. Let's figure out X-intercepts.
Goodness sakes.
All right. X-intercepts. We're going to factor the top. Plot a 6 and an X, and so we'll be left with an X minus 2.
Crap, let's have kids at the same time.
All right.
Okay.
Anyway.
With each other.
Not fun. Take the next couple plays off. All right. So we're gonna make each of these zeros. So this one, the X-intercept would be a 0. The X-intercept here would be a 2. So. Oh wait, we wanted to make this balance. That's fine. I was not thinking that.
You wanted to.
No, let's do this. We can modify it slightly. Hold on. Hey, hold on. I'll make a slight modification so we can make one of the X-intercepts bounce. So here's the only modification I'm going to make.
Oh, that was gonna be a nasty graph. I
3,
thought.
and let's go with an X squared. There we go. that way we can still make it bounce. We're just gonna take out 2 x's in the beginning. We're gonna take 2 x's. It's still the same problem. I just made the powers a little bit bigger. Sorry, I want to make one of the X-Intercepts bounce. All right. Okay, did everyone see the slight modification I just made? Okay, so I pull out an x squared and a 6, and then so it's still factored out the same. It's just I want to make sure the multiplicity here, so it bounces off this one. So this has a multiplicity of 2, so we will bounce off of that X-intercept, and we're going to pass through this one. So bounce off of 0 and pass through 2. Okay. Questions? No questions? All right. Now, let's do the vertical asymptotes. So, okay, vertical asymptotes. We're gonna factor this thing apart. So we need to. So for the vertical, we need to factor the denominator.
It already bounces off the bottom.
Verticals don't matter. I forgot to make the top bounce. That's what
The bottom one doesn't.
Bottom doesn't matter. When you do vertical, it doesn't matter if it bounces or not. So, all right, we're gonna pull out an 8 for common factor. Okay, and then we're gonna factor that thing apart, so it ends up being x plus 2, and so my vertical asymptote will be at -2. Now, notice this thing right here that doesn't have a vertical. It doesn't have a variable in the outset. And it doesn't matter that it bounced. When you do vertical, you don't put the multiplicity in mind. It's only for X-intercepts. Question?
So I didn't take out that 8. Does it really matter?
No.
I still got a -2.
Yeah, it still would work. Even if you didn't pull out the 8 and you're trying to use the front number to make the front and the back number to make the 32, it would still work the same way. It would just take you a lot of time to do it. As opposed to what I just did, making the numbers smaller. But yeah, it didn't matter how you factor. You still got the same number because you said each of those comes equal to 0 and solve. It still would have been -2, -2. So, all right.
I wasn't thinking. I didn't know you could.
Yeah.
I still did.
Okay, so we have the vertical. So this picture has 2 drawings. So this thing has 2 drawings. And so what we're going to be looking at is, on this particular case, the top power is bigger than the bottom. And so this one wouldn't have a horizontal asymptote anymore. It won't have one, sorry. I modified it, it doesn't have one, sorry. But we do have to worry about where do the tails go on the outsides, because it doesn't have a horizontal because the numerator turned out to be too big. The numerator is bigger than the bottom. Now it is by 1, so we could long divide this thing to figure out where the slant is, because it would have a slant, not a horizontal. So, but is there any questions with the first 2 parts I've done up to this point?
Is it there a slant or a horizontal?
There's a slant. It's not quite horizontal. Slant's different than horizontal.
Yeah.
So,
Oh yeah.
yeah. All right. Is there any questions with X-intercepts versus Y-intercept?
No.
Okay. Oh, sorry. Vertical asymptote versus X-intercept. All right, now we have to do Y-intercept. So the Y-int.
0.
Y-int. Yeah, I think we already hit 0, 0. Because when you plug in zeros to all the x's, it's 0 plus 0 all over 32. And so 0 divided by 32 is still 0. So it's still going to hit the x or the y-axis right here. So you can even see it. All right, now.
Isn't it 1/32 of 0?
Yes, which is still 0. All right, now.
Well, I know it's kind of a wild concept.
Yeah.
It
Now.
really is.
Okay. Now, we have to talk about the horizontal and slant. This thing, I told you earlier, it doesn't have a horizontal. It doesn't. There is a slant. Now, the reason why there's a slant is because the top is bigger than the bottom. So top is bigger than the bottom, but only by 1. Only by 1. So it does have a slant asymptote. So it's not perfectly horizontal. It's going to be a little bit of a tilt. And once I have that tilt put in there, then I can draw it and do the best that I can. Okay, and then I can kind of figure out where this thing's going to go. I do need to draw the slant because I'm kind of at a point where I don't know exactly where this graph is going, because obviously I don't have any X-intercepts over here. So it's going to be kind of limited to where it's going to be. It can't cross the x-axis over here. So I really need to figure out where the slant line is.
No, it can't cross the vertical.
So, okay, is there any questions with up to this point?
There's no X-intercept.
Okay, let's do division here.
Bad deal, so I don't know.
Oh, that's what it was going.
So, what's this, what is,
Do the top, I kind of do it for myself.
so there is a horizontal one though, right?
No, the numerator is bigger than the bottom, so there is no horizontal, but there is a slant.
And it's,
Because slant is when the top is bigger than the denominator by 1 degree. That's when you have a slant. That's the fourth rule I didn't have here.
So it's 2/3 is subtract that, right? Or is
So,
that-
well, we have to divide, so
Yeah.
we just have to do a couple here, so. All right, so gotta put this in the house. I'll put another 0x and some zeros. And then on the bottom, 8x squared plus 32x plus 32. All right. Okay, so what do I take times an 8 to make 6? So this is ugly. So I'm gonna have to multiply by, I'm gonna multiply by 6/8 and an x, because that, so yeah, so 6 divided by 8 is 3/4. So if I multiply by 3/4, like somebody said, the idea is that that will make it into a 6x cubed. So 3/4 x, or just 6/8. When I multiply by that, this will turn out to be a 6x cubed. When I multiply by 3/4 on 32, that'll be a 24x. Because again, how I'm doing that, I'm dividing 32 by 4 and then multiplying by 3.
What
So-
did you do, square?
Squared, thank you. And then 32 times this again, that'd be a 24x. So that's, again, that's taking each of these items times 3/4, you divide by 4, multiply by 3, this is how I do it. You switch all the signs. This turns out to be a negative 36x squared, a negative 24x, and a 0. And I have to go one more step so I can draw this thing. So what do I have to multiply on an 8 to make negative 36?
4.5.
Yeah, you're right. It's like 9 halves, isn't it? So you have to divide by, so this, it would be 36/8, which is 9 halves, and it'd be negative.
Yeah.
Oh, just by that. I don't even have to multiply by number. So that'd be 9 halves,
negative 4.5.
negative 4.5. Because if I divide by 8, that'd be 36, and yeah, it has to be negative. So, all right. So this is my linear equation. This is the slant. Yeah, it's really bad. It's negative 4.5. 1, 2, 3, 4.5. And then it's going up 3, 1, 2, 3, and over 4. 1, 2, 3, 4. Up 3, over 4. 1, 2, 3, 4. And here is my slant asymptote. So I can get a view of what's happening here. I have already kind of an idea what's taking place by putting that slant. That on the left side of my graph, this thing, my other graph, is down here. Now, how I know that is because I didn't touch the x-axis up here. So it had to be down, it had to be squeezed in like a little corner, so it wouldn't touch the x-axis. And up here, we had a multiplicity where I actually bounced off of the 0, and it passed through this one. So it was probably something like, it was, oh, I gotta pass through that X-Intercept, so it's gotta be,
It crosses the
It's
slope.
not pretty.
It's gross.
yeah.
Okay, slant.
So how would I bounce? So it probably does something like this.
What about
Bounce,
vertical asymptote?
pass.
shirt on right now.
It probably does
No,
something
it's
like
not.
that.
What about the other vertical asymptote, the
I
8?
don't understand what's happening.
So, yeah, that's gross. Okay,
What about the 8 vertical asymptote?
for which one?
This one we're doing right now. There's another vertical asymptote, right?
No.
What
The-
about that 8 that
The 8 didn't matter. It didn't have a variable, so it didn't count.
I'm just kidding.
Yay.
Okay, so anyway, the graph, is that right?
Wait, so where'd you get the Y-intercept?
Oh, for the slant. For the slant, it's right here. When you long divide the top and bottom together, this equation, when you long divide, it gives you the equation for the line that you have to draw. So I had to multiply by 9 halves to turn this thing into a 36.
Will you type this baby in, Jared?
You're good.
How you do it is whatever number you want to turn it into, put that number on the top, and whatever you want to divide off, put that number on the bottom. So 36 over 8 is 9 halves.
Dum, 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 dum.
All right, you don't have anything that difficult. Oh, sorry. All right.
Hold on.
Okay. All right. Here we go.
Hold on.
Due by the end of the week, Friday.
So, 2 weeks from now?
Okay, can we, Friday, 2 years after Christmas.
No? Where are we supposed to annotate? Look,
Thank you, Ward.
Well, when you go on campus, how has that couple of questions you can answer the walk That's what we're supposed to answer? Well, it's pretty much just like how they're comparing, how they're comparing.
Have you done it yet?
I haven't even printed it out yet. I'm gonna print it off next year.
I'm not even, I'm studying all that.
me.
Ward, I have a challenge for
Thank
you.
you for blessing me with this homework.
I don't want to
Is that
do
Friday?
I'd rather stay in study hall.
So Morgan, make sure you get a couple screenshots of us.
Are you the only person?
I'm the only person that even is my study.
My girlfriend said that she doesn't think I'm very smart. She doesn't think I can figure it out. We figured it out, so it looks like I did it.
This is it.
A half done proof, right?
I had tried to.
It's like proof, but it's like half done.
We don't have that information.
Okay, so I'm doing factor world.
Yeah, it's figured.
Okay, so
Zoom in on that, maybe. I can't even see it.
Yeah, true.
you can zoom
What I
more.
got for you? Absolutely not. It didn't?
So now we gotta get common denominators, or is that a common denominator?
I always go over. Like, no, I
Where's
might just reverse French.
Where's the?
This is statistics, but follow the basics.
Yeah. She's in stats, not calc.
Yeah, it's statistics. That's the problem. I'm trying to figure
Let's
out.
just get Wise in here. She'll rip through that thing.
Will she? Yeah, she would.
Is she back now?
Yeah.
Can I see if she's busy?
She's in stats. You might.
Easy.
We're gonna use.
Hey, how about I print this off?
I will never use that.
Plus squared.
I will never.
Same power, what are they
Have
doing?
fun doing
You mind if I print this off?
No, no problem at all. We need to figure it out so it looks like I'm smart.
Well, you are.
We need to be convincing.
Graphing is directly. Brayden, what's the rule to have the same degree?
What are you talking about?
If they have the same.
The assignment.
What Wyatt? What board?
Alright, Wyatt, here's the deal.
Wyatt, what's up?
My girlfriend's in stats. She doesn't think I'm very smart. She sent me a proof. Like half finished proof. And I need to figure it out and send her the answer back.
No, that's one the denominator.
As if he did it.
As if I did it myself.
This is a terrible idea, but
Let me see this. A proof?
all right. You want to pull up that picture again?
What? Oh, proof.
Yes, it's a
Look,
stat.
And then we just gotta hit
Never
print.
in my life when I do
Proof of this.
All right, so hit print on that bad boy.
Hit
Hit like the share tab and print. Do you save to your
Ryan's on here.
Oh, I was like, are you just recording yourself there?
No, Morgan is the person where I have her write notes on an iPad so people at home can see
I
it.
remember there was one class.
So,
That's when you.
Oh.
because they're having problems with the glares on the board.
math.
So I just write on an iPad, so we have two notes going on.
Yeah.
And they can still see me.
I hope it's the brother
Next
one.
semester.
Look at work.